Welcome to today we're going to be learning how to use your graphing calculator. Basically, the section is entitled Solving Equations and Inequalities Graphically. So I'm going to take this opportunity to really orient you to your graphing calculator. So if you don't have that in front of you before watching this video, I would suggest going ahead and getting that in front of you so that you can follow along with the different functions that we're going to be investigating as we go through this video today. Okay, the first thing I want to start with is just a startup from the problems from last class. So if you want to try these problems here and check your answers, you can do that. Okay, so we want to look at both solving equations and inequalities graphically. Because what happens is some equations are just difficult or even impossible to be solved algebraically. So maybe we're unable, maybe it's not a quadratic, maybe it's a higher degree polynomial, and we're just not able to use algebraic methods to get an answer. And in that case, we have to revert to using a graphical method, specifically our graphing calculator with this. So when we start to look at the difference here, if I had this equation, 3x minus 4 equals 1, that's a simple linear equation. We could easily solve that and get our answer. But we could also have graphed it to get the answer. So what you would do in this case is looking at this, you would graph the line and you would be looking to see where it crosses the x-axis, because the place it crosses the x-axis is going to be our solution to our equation. Okay, so the advantage of an algebraic method is that it gives an exact answer. And I guess you'd say the disadvantage of the graphical method is that it is only an approximation to the answer. It's a good approximation depending on how many decimal places you're able to get your answer, but it's not going to be an exact answer. Okay, so just to kind of compare here, if we look at this equation and we were trying to solve it algebraically, I could do the quadratic formula for this. It's a quadratic, do the quadratic formula, and this would be an exact answer that I would find. But if I look at the graphical method, what I'm going to be looking at is this is the graph of this equation that I'm working with, and this is going to be my answer here. And we're going to focus today on using the calculator to get the coordinates of these points here. And if you were to get the coordinates of the points, you would see that they would be a decimal that's equivalent to this exact answer that we could get algebraically. If we look at one like this one could be factored and we'd find that our solution is x equals 2. So it's very easy to solve this one algebraically. Graphically, you can see that this graph actually just sits on the x-axis, and so our answer would also be 2 that we could get from the graphical method as well. And then looking at this one, if you solve this using the quadratic formula, which would be our algebraic method, you see that you end up with an I in your answer, so you have a complex solution. So basically, we have no real solutions, and because we have no real solutions, we would expect to have no x-intercepts, so our graph is not going to be touching the x-axis when we look at it. So this would have no real solutions when it doesn't touch the x-axis. Okay, so the first thing I want us to talk about is setting your window. This is really important. I'm going to look at this example. So if you want to go ahead and type this into your calculator, you'll go and put it in for Y1 in the calculator. And if you're not, depending on how familiar you are with the calculator, if you need more help than what this video gives you, that's fine. Just let me know. We always want to start by choosing a Zoom 6, and that's going to give us our standard graph. So this is just what I would recommend doing for every new problem. So as you move from one problem to the other, just start by doing Zoom 6 for your standard. This looks at the window from -10 to 10 and -10 to 10. But what we have to understand is that that's not always going to show all the characteristics of our graph. Sometimes we need to adjust the window to be able to see that. So in this case, it looks like this equation is a line, and we know that it's not a line because it has a cube here. So what we're going to have to do is we're going to have to adjust our graph. Okay, when we adjust the graph, we want to go to the window button at the very top of your calculator, and you've got your x min, your x max, your y min, and your y max that you'll need to adjust. I usually do not do much with the x scale and the y scale. Very rarely do I change those. So for this one, if you want to play around with it a little bit, you can. I know some people use the zoom features, and that's fine if you like that. I just prefer using the window to change because I think it helps you with domain and range also, because these are going to kind of represent your domain values, and these will represent your range values that you're seeing on the graph. So looking at this, when I adjusted it, I actually left the x's the same, but I adjusted the y's. So I'm now looking down here at -30, and I'm looking up here at 20, and it lets me see this curve that I needed to be able to see in the graph that I was missing when I looked at this standard window here. So first thing, always adjust your window to find the characteristics that you need for that particular problem. Okay, here are a couple that I'd like for you to try, and I'm going to switch over to my calculator and go through these as well. Okay, for the first problem that I ask you to do, if you go to y equals and type that in, that's where you'd want to go to get this typed in. And then I'd like for you to start with zoom number 6, which is zoom standard. Zoom standard gives us this window. Okay, so it gives us our standard window from -10 to 10 and -10 to 10. As you can see when we look at the graph, it looks like a quadratic, but it's showing to be a cubic function. So we're missing part of our graph. So that's where I want us to go in and change the window. So here we're going to have -100 and then 150. So the first interval that they're giving you there is -100 to 150. And then our y min is going to be -2000. And we're going to go to +2000. And then we're going to graph that. Okay, so we see this curve that we were missing before. So before with just the standard window, we only saw this part, and now we can see this other part with the new window. For the second example that I ask you to graph, you would put this in x divided by x squared plus 25. Be sure you put parentheses around the denominator or use the fraction button that some of you are used to using. So if we start with the standard window, you actually, this looks like a straight line, but there's a lot of characteristics being hidden here. So we want to go in and change our window. So if we change our window to the recommended values on the interval on the in the directions, you've got from -50 to 50, and then from -0.2 to +0.2 that we want to change it to. So once we have those changed and we look at the graph, you can see that this graph shows a characteristic of the graph that we were totally missing before. We had to zoom in on the x-axis here in order to be able to see that better, and we can see a lot of characteristics. We have a minimum, we have a maximum, and so forth that we didn't see before when it was zoomed out so much. So now that we know how to adjust our window, we want to move on to finding the zeros, which is the same thing as solving an equation. If we're asked to solve this equation using your graphing calculator, basically what we're doing here is we are looking for where this is equal to 0. We're going to give only our x's as our answers with that. So the first thing we want to do is we want to go in and put this equation in for y1. So the equation we're working with is 2x to the third minus 3x minus 15. So enter that in for y1 and get an window that's going to work for you as far as being able to see the characteristics of your graph. From here, in order to find those, what we want to do is we want to go to second and trace. Okay, and once we're at second and trace, that brings up the calculate menu. And from the calculate menu, we're going to choose number 2, which is 0. Once we choose that, what we're focusing on is we're focusing on finding this point here. So we have to tell the calculator what it asks for, the left bound. You can either type a number here or you can actually use your arrow keys to move the cursor so that it's over here somewhere. You just want to make sure that I'm somewhere to the left of this point that I'm trying to find. Okay, the next question is going to come up to find the right bound. So with the right bound, again, we want to be somewhere to the right of this point that I'm trying to find here. Okay, so I choose a left bound and then I choose a right bound. I can type those in. So looking at this, it looks like this is close to 2. So I might type in 3, or I could just use my right arrow key to move to the right, whichever works best for you. The next question it's going to ask is the guess. So for your guess, you want to take the cursor and move down as close as you can to this point. Or if you want to type in a guess of 2 or 3, whichever you want to type in, somewhere in there, whatever it looks like it's close to, then you can type that in, or you can use the cursors again to move that. Okay, once we get here close to this guess, press enter, and then at the bottom you're going to see this as your answer. This should be 0 or something very close to 0. Sometimes it might say like E negative 99 or something really, and that's just scientific notation for a really small number. So sometimes the calculator will round things kind of funny. But this is the 0, and that's the solution to this graph. So you've solved the equation 2x to the third minus 3x minus 15 equals 0. Excuse me. And we found that that answer is 2.21. And it just depends on your directions as to how many decimals to give here. But that's what we would get when we solve that. And that one's not one that we could easily solve algebraically. Okay, here are 2 that I would like for you to practice with. This is going to be your x min and your x max that they're giving you. It's not giving you the y's on these, but when it restricts it to this interval, then even though there may be other solutions to this graph, you're only looking for the ones that are between -2 and 2. So essentially we're solving this as if it's equal to 0, and you'll get your answers between -2 and 2. Right. For our first problem, we want to be sure that we go to y equals and type our equation in here. And then after we have the equation typed in, we want to go to Window. Be sure that you've done Zoom 6 to start with, and then go in and change your x minimum to the -2 and x maximum to 2 with that. Okay, when we do that and graph it, we see a graph that looks like this. And so our solutions are this point here and this point here. So what I'm going to do is I'm going to go to my calculate menu, so second and trace, and I'm going to choose number 2. Okay, so it's asking me for a left bound. Let's focus on this 0 here first. So a left bound for it, I might take and either move my arrow key, take my arrow and move it over until my cursor is slightly to the left of this point here. So it just has to be somewhere to the left. My other option is actually to go in and just type in the -1. That would work as well for my left bound. Okay, so now I want to go to the right bound. So again, I can either use my arrow key to move it to the right. Okay, so as long as I'm somewhere to the right of this point, doesn't really matter how far. I don't want to be way over here, because then the calculator gets confused that I'm working with this one. So I want to be somewhere close to this, but to the right. And again, if I want to type this in, I can. If I type in 0 and then press enter. Okay, so what I see here are 2 arrows, and they indicate that I'm finding the 0 that's in between these 2 arrows. So now for my guess, I can take my cursor, move it back up, or if I want to type in like 1/2 as a guess, I could do that. So that's my guess, somewhere in there. And I went a little further than I meant to. Okay, so as long as you're pretty close, that's good. Press enter. Okay, and here is our answer for that one. So our answer, I think it asked for 2 decimal places, so -0.49 for our answer. One thing that I failed to mention on the previous example is that we did have 2 zeros, and we would need to go ahead and find that second 0. So if you found the second 0, it should be at 1.74. Okay, moving on to the second example here. If you type this in, you get, you put x minus the square root of x plus 1. To get your square root, it's second and this, and then I'll bring up the square root symbol right here. So from there, you want to do your zoom 6 to standardize it and then go in and set up your window. So they're giving us the interval from -1 to 5. So that's going to be my x minimum and x maximum. So I'll press graph. Okay, so we're looking specifically at this interval. Really doesn't matter what's happening outside of that, but we want to check on this. So here is going to be the 0 that we're looking for. So I'm going to go to do second trace again. I'm going to choose 0, and then I'm going to go slightly to the left of that and press enter. Again, I could type these in if I wanted to. I'll go slightly to the right, press enter. And then my guess, I'm going to come pretty close and press enter. And here's my answer. Again, if yours is giving you something like E -99, then that might just be from rounding. So don't be too concerned about that if it's not showing 0 here. Okay, the next concept that we want to look at is finding points of intersection using your calculator. So you would want to find a point of intersection when you have an equation equal to another equation here. So basically we want to find out where they equal each other, which is where they intersect each other. Okay, when we put this in the calculator, what we're going to do is we're going to go to y1 and put one side of the equation, and then for y2 we're going to put the other side of the equation. So when we look at the graph of these, and this is an adjusted window because you can see the scale is different on the vertical axis here, we're going to see where they intersect each other, which is this point here. That's the point that we're trying to find. It is not enough to use your trace key and trace over to that point. You have to go through this process. That's true for finding the x-intercepts, and it's true for finding the points of intersection, and also for the maximums and minimums. The trace key will not be accurate enough for these answers. So if we go and go through this process, we're going to go back to the second and trace like we did before. And so when we do second and trace, it's going to bring up the calculate menu. And so we're going to be choosing intersect this time, which is number 5. So if we do that, then what we're going to have is we're going to have to find this point of intersection here. And it's going to ask us a couple questions. The first one is, what's the first curve? If you look up here and it shows the first one you put in, which it is going to do that, then you just press enter and then it'll advance to this next one. The only time that's going to be an issue is if you happen to have like 3 or 4 equations and it was wanting to know which 2 you want to check the intersection of. If you only have 2, then that's not an issue. So down here for the second curve, just make sure it says whatever your second curve is, which is this line 3x minus 2. And then for the guess, we're going to use our arrow key and move our cursor as close to this point of intersection as possible. Press enter, and we're going to get this as our point of intersection. When we're solving it as an equation, our answer is just going to be this x because that's the part that solves the equation. If you look back, we don't have a y in this, we only have x's, so we just want to give the x as our point of intersection. So here are 2 problems that I would like to for us to practice with on your calculator. So try these 2 problems, and then I'm going to go over them and show you on my calculator how I would have done them. Okay, on this one, this next one, you want to put your 2 equations in. So we've got 16x to the third plus 16x squared for y1, and then y2 we've got x plus 1. We want to do zoom standard and then go in and change our x min and x max. So the interval was 0 to 2, so we want to change those to 0 and 2, and then press graph. When you press graph, this is the point of intersection we're trying to find where the 2 equations are equal to each other. As I said before, it is not sufficient to simply trace across to that point. You have to go through this process of doing second and trace and finding your point of intersection. Okay, so our first curve, we're going to make sure that it shows up here. So our first curve is correct. Our second curve is correct. And then we want to move close to the point of intersection. Okay, so we'll move over here to the point of intersection and press enter. And here's our point of intersection. So the coordinates are 0.25 and 1.25. Since we're solving the equations, they only have x's in them, so this is going to be our answer here, the 0.25. If you looked at the bigger picture, these two graphs actually intersect 3 different times, but the only one that's between 0 and 2 on that interval is the 0.25, and so that would be our answer for this one. Okay, so for the second problem here, if we look at this one, we've got for y equals, we're going to enter our first equation, which was 1 plus the square root of x. And then the second equation was the square root of 1 plus x squared. Our interval was from 1 to 5, so we'll change that. And then when we press graph, you're going to see something that looks like this. So our point of intersection is right in here. So I'm going to do second and trace. Again, do not do just trace, do second and trace. We're finding the point of intersection. So we'll check our first curve. So here's our equation for our first curve. Our second curve looks correct. And then we're going to do our guess. So we can move the cursor down a little closer if we would like. Somewhere in there, and press enter. And here's our point of intersection. So the x coordinate is going to be the solution to those two equations being equal to each other. Okay, here's one more example of solving two equations equal to each other. So put this one in for y1, this one in for y2, and use the interval here from 1 to 6. So picking up back over here on our calculator, if you've entered this equation for y1 and this one for y2, check your window, make sure you've changed this to be in from the interval from 1 to 6. And then you see on the graph here, we actually have 2 points of intersection, which means we have 2 solutions. So we're going to do second and trace, choose our point of intersection. We're going to do our first curve and then our second curve. And then for our guess, we'll go over and choose this first one. Okay, press enter. And you will see this as your intersection point. So that would be your first answer. Round it to the appropriate number of decimal places. Then we're going to do the second part here. We'll define another point of intersection. So check your first curve and your second curve, and then move the cursor all the way over to our second point of intersection, which is over here, and press enter. And so here is our second point of intersection, or our second answer. Okay, another concept that we want to be able to do with our calculator is to solve inequalities. So here we have 2 equations, but instead of an equals, we have a less than or equal to between those. What we have is we have a parabola and we have a line. So if you put this in for y1, you're going to see that you get this blue graph here. And if you put this in for y2, then you're going to get the line. Okay, so what we're interested in here is knowing where the parabola is less than or equal to the line, or where the parabola is under the line. So in looking at this, we clearly can't see all of our points of intersection because we're missing something up in here. So we're going to adjust our window. And in doing that, when we adjust our window out from the x's work fine for standard, but the y minimum we need to, we can leave it the same, but the y maximum we need to at least move that up to around 30. We're looking to see where the parabola is below the line. Okay, so less than or equal to is going to mean below. So that's this part in here. Okay, so what we're going to do is we're going to find this point of intersection, and we're going to find this point of intersection, and then it's going to be all the values between those. So if we go through and we find the first point of intersection, doing the process we just got through doing, we'll see that it's going to be this first coordinate here. So that's the x coordinate of this first point. If I come over and look at this part here, then that's going to be the 5.3. So I've got this first one is going to be at negative 0.3723, and then this other one is going to be over here at 5.3723. So we're looking at all the values in between here as our answers. So we would write our interval as the interval with closed brackets because we've got the equals part here, and then that would be our answer. Okay, here's one that we want to look at graphically as well. So here we're looking to see where the parabola is less than or equal to 0. And I'm going to switch over to the calculator to take a look at this. Okay, so for this one, if I go and I put in my equation here, because it's compared to 0, I'm going to go ahead and put 0 just so we have a reference point there. And if I do my zoom 6, okay, this is the point I'm interested in here because I want to know where the parabola is less than or equal to 0. So 0 is the red line and the parabola is the blue line. So it's this little part in here. So what I'm going to do is I'm going to do zoom, and you can do zoom in, zoom out, but I actually like zoom box. So with the zoom box, what you do is you can take your arrows, move them up. Okay, and then when you get to what would be the corner of a box, press enter. And then we're going to drag that box down and over until we kind of have in the box the part that we're interested in looking at. Okay, and I'm actually going to go a little further down just to make sure I get everything I need. Press enter, and it's going to zoom in on that section that we're interested in. Okay, so I want to know where the parabola, which is the quadratic, where that's less than or equal to 0. So that's going to be this part in here. So I'm going to do second, calculate my point of intersection, and I've got my first curve, my second curve, and then I'm going to actually type my guess in here because my guess looks like 2, and it turns out 2 is correct on this one. And if you look, 3 is also going to be correct. So the part that you're going to give is you're going to give the answer from 2 to 3 with brackets on each of those, a bracket on the 2 and a bracket on the 3. Okay, here are 2 inequalities that I would like for you to practice with. So if you will, enter these in your calculator and try to solve these. Right, for our first example, we'll go to y equals and we'll enter our 2 equations here, x squared and 3x plus 10. And then when I first graphed using the zoom 6, what we see here is that we don't see both points of intersection, so we need to adjust our window. So I actually changed my window for the Y max. I changed that to 50. You may not have needed to go quite as high as 50, and then press graph. Okay, so we see that we have 2 points of intersection, and we're interested for where x squared is less than or equal to the 3x plus 10. So when we look at this, we've got to find these points of intersection. So I'm going to do second, trace, and our point of intersection, and our first curve, press enter, our second curve, press enter. And I'm actually going to type in my guess. I think, well, I actually accidentally pressed enter again, and it took me to an intersection of -2. So I'm going to repeat that process and find my point of intersection again, and that's going to be this value that we come up with here. So I'm going to just type in maybe 5 for my guess. Okay, and so I actually was right on that. So my point of intersection would be 5. So in looking at this, it looks like the parabola is less than the line from -2 to 5. So my interval would be a bracket with the bracket -2 comma 5 and another bracket on that. Okay, on this next example, if we enter in -2x squared plus 5 and then x squared minus 8, I will say be careful that the calculator doesn't like subtraction signs for negative signs. So a negative is going to be this button and the subtraction is going to be this button. So this one needs to be a negative, this one needs to be a subtraction. Okay, from here, we want to go ahead and graph this. And when we graph it, we can see that we have this graph. The problem is asking us for where the -2x squared, which is the blue graph, is greater than the red graph, okay, the x squared minus 8. So that's going to be this part in between here. And while this still looks like -2 and +2, it's not enough to just guess that. So let's go through and do our process here for finding the points of intersection. First curve, second curve, and then I'm going to type in -2 for my guess. Actually, let me do that over again. Okay, so it's not exactly -2. There's some decimals associated with that. And if we do this process again, we'll find that this is actually the positive with the same number here. And so the interval where the blue graph is greater than the red graph is going to be the interval from -2.08 to +2.08. Okay, the last thing that we want to look at here is finding local maximums and minimums. So we're going to put this in for y1 and find the maximums. So once we have that in for y1, we're going to choose, if we're looking at our graph here, this is a maximum, a local maximum, and this is a local minimum. So I'm going to go through and find the maximum. So I'm going to choose number 4 for maximum. It's very similar to the x-intercepts. You'll choose a left bound, and then you're going to go in and choose a right bound. It's just this time we're focusing down here on the maximum and not the intercept itself. So you'll do a left bound, a right bound, and a guess, and then you're going to get the coordinates here for a maximum. So our maximum occurs at this value, and the actual maximum value is this value here. Okay, so here's 2 for us to practice with. Okay, on our first example here, if we enter our equation in for y1 and then do zoom standard, you'll end up with a graph that looks like this. So when we're trying to estimate our maximum, this is going to be our maximum here. If you want to zoom in on this section, you can, but we're going to go to second and trace. And this time we're going to choose maximum. So we're going to look at our left bound. Again, you can either type the number in or use your arrow keys, press enter. We're going to go a little bit to the right of the maximum, press enter, and then come back up to the peak and press enter. Again, you can put these values in as well. And so we see that we have a maximum that's listed here. So that would be the ordered pair, the xy for this particular point here. So the maximum occurs at the x value, and the maximum itself is this value. Okay, so we're going to do the minimum here. We're going to find this minimum. So we're going to go second, calculate. This time we'll choose number 3 for minimum, and they're actually done exactly the same way, except we're focusing on the minimum. So we'll go left bound, come over and go right bound. So we're looking to find the minimum that's between these values, between these arrows here. Okay, so our guess, again, you can always type these in. Let's just say our guess is 0.5. Okay, and so the actual minimum is 0.577. So this is another type where you do not want to be tracing. You want to actually use these functions on the calculator to get exact answers. Okay, our last example for the day is going to be this one, that is 3 plus x plus x squared minus x to the third. Okay, so I want to graph this one. So we've got a minimum here. So we're going to do second calculate minimum. And I'm going to type these in this time. For my lower bound, I'm going to say negative, actually let me say -2, because I want to make sure that I'm far enough to the left of that. My right bound, let's just say 0. And my guess, I'm going to guess 1 or -1. So I find that I have a minimum of negative, this is -1/3. And the coordinates of that would be -1/3 and then this 2.814. Okay, if I want to find the maximum over here, then I'm going to go to second and trace. I'm going to find number 4 for maximum. Left bound, I'm just going to put 0 in. You don't really have to be all that exact with this. My right bound, I'm going to put 2 in. And my guess, I'm going to put 1 in. And enter. And so here's my maximum. My maximum is at the 0.14. So the maximum occurs at 1 and the maximum is 4. And these are local minimums and local maximums. We'll talk more specifically about that later. But I just wanted to kind of include everything with the calculator today so that you'll be good at doing that. One thing while we're here talking about the calculator, just to kind of remind you, I know some people know how to do this, but if you have a decimal like 2.25 and you want to convert that to a fraction, if you go to math and number 1, then that's going to convert that to a fraction for you, the fraction 9/4. So just a little helpful piece of advice if you don't already know about that. Okay, so that concludes our lesson for today. If you have any questions, feel free to contact me. Be sure you're keeping up with your WebAssign work, and I'll see you next